For this video, we are going to discuss frequency polygons and ogives. Yes, that does look like ogives, but it's actually called ogives. So the first one that we're going to discuss is the frequency polygon. We need the same information as whenever we were creating a histogram, but it's a line graph on this one. It uses the class midpoints for it. Whenever we're talking about midpoints, we need to be able to actually calculate them. So the midpoint of a class is the average of its lower class limit and the lower class limit of the next class. So we take the lower class limit plus the lower class limit of the next class and we divide by 2. Remember whenever we were talking about class width and we added the class width down to get the lower limits first? Well, those lower limits that we found is what we're going to use right here for our class midpoints. So we're going to go back to our Old Faithful data. We have the data here. We've actually already calculated the classes, the frequency, and the relative frequency. Now what we need to do is we need to calculate the midpoint for each class. So the midpoint for the first class, I'm going to take 670 plus 680 and divide it by 2. And I'm going to get 675. So I took this class limit plus the next lower limit, added those, and divided by 2. Now if you recall, when we calculated the class widths, we said that the class width was 10 in this particular case. And if you recall, I told you that we added the class width down to get our lower limits. We got our first upper limit, and then we could add the class width down. We can do that exact same thing with midpoint. We could also calculate the midpoint for each one, 680 plus the next lower limit divided by 2, and I get 685. But notice there's a difference of 10 here. That means that there's going to be a difference of 10 between each midpoint. Now if you're unsure of that, go ahead and calculate them and see what you get. So after we have calculated these, which we need for the frequency polygon, we're going to construct a line graph using the midpoint along the x-axis and the frequency along the y-axis. You could use relative frequency if you wanted to. I want to use this data here. So first thing I'm going to do is I'm going to draw my axes. My first midpoint was 675, 685, 695, 705, 715, 725, and 735. Now these values represented our eruption times. I'm sorry, this was actually time between eruptions. So let me get rid of this. It was time between eruptions. And that was measured in seconds. On the y-axis, I'm actually going to continue using the frequency. For me, it's a little bit easier. We have the largest frequency as 11, so that means I need to go up to at least 11. So there's my 11, counting by 1. And now then, what I can do is I'm plotting these points. 675 with 2. So 675 with 2. I'm going to put a dot. 685 was 0. Well, that one's kind of easy. That one's right there. 695 was 7. So I'm going to put it up at 7. 705 had 9. So I'm going to go up to 9. Well, 715 also had 9. So I'm going to stay at 9. 725 had 11. And 735 had 7. Since this is a line graph, I'm going to connect my dots. And I just connected the wrong dots because I skipped one. So let me do this again. I go down to 0. Then I go up to 7, 9, 9, 11, and 7. This is what we call a frequency polygon because it has different sides. Remember that a polygon is a figure with different types of sides. It could be a square, it could be a triangle. Those are special types of polygons. It just means multiple sides. Well, I have multiple sides here, and it changes a little bit of direction at each intersection. That's why it's called a polygon. The last type of graph that we want to discuss in this area with the quantitative data is what we call an ogive. It's spelled ogive, but it's actually pronounced with a J sound, an ogive. It's another type of polygon. So since it's a polygon, it's going to be some type of line graph. Instead of using just the frequency, though, it's going to use the cumulative frequency or the cumulative relative frequency. Whenever we talk about cumulative, basically that just means we've added them all up. We've accumulated them. So we've added up to that point. So if you think about this, our upper limit here is 679. How many values are 679 or below? Well, there's 2 of them. How many values are 689 or below? There's still 2 of them. What I did was I took 2 plus 0 and got 2. Below 699, I took this 2 right here, my previous value, and I added 7 to it. Now I'm going to take this 9, or if you want to, it may be a little bit easier for you to see. 2 plus 0 plus 7 plus 9 is equal to 18. And we just keep adding the next value down. So I get 27, I get 38, and I get 45. What I did here was I took 18 plus 9. I took my 27 plus 11. And I took my 38 plus 7. To get the cumulative relative frequency, remember that relative frequency was the frequency divided by the total number. Well, we're still going to use this total number in being 45 total data points, but instead of taking the frequency, we're going to take the cumulative frequency. So I'm going to have 2 divided by 45. And you will notice my relative frequency for the first one is the exact same. Cumulative means I'm going to add these 2 together. So 0.0444 plus 0 is going to be another 0.444. Or it could be my 2 divided by 45 again. Now for the third cumulative relative frequency, I'm going to add all 3 of these up, and I'm going to get 0.2. That's the same thing as 9 divided by 45, taking my cumulative frequency, dividing it by my sample size. I'm going to do that all the way down. So I get 0.4, 0.6, 0.8444. And this last one, remember, if I add all these frequencies up, they should come out to approximately 1. My last one should come up to approximately 1. Now for an ogive, we are going to construct another line graph. So frequency polygons and ogives are both line graphs. This time we're going to use the upper class limit along the x-axis and the cumulative frequency along the y-axis. So if I draw my lines here, my first upper limit was 679, 689, 699, 709, 719, 729, and 739. This was time between eruptions. You'll notice that I am labeling my x and y axis for everything, including my units. I want to make sure that I'm as accurate as possible so that if somebody looks at my graph not looking at the data or the description of the data, they can still tell what this is. Over here I'm going to use the cumulative frequency. Well, in this case I go up to 45. So I'm probably going to have to count by, let's say, 5s. I could have spread them out a little bit more, but that's okay. There's 5, there's 15, this one's 10, this one's 20, this one's 25, 30, 35, 40, and 45. So I could have spread them out a little bit more, but that's okay. It just makes it a little bit more difficult to actually draw the line, because at 679 I was at 2 for my cumulative frequency. 689 I was again at 2. Then I went up to 9, and then I increased to about 18, then to 27, then to 38, and lastly to 45. One thing about an ogive is once you start, it never goes back down. So I'm constantly either staying the same, like I did here, or increasing. If you recall, with the histogram as well as the frequency polygon, let's go back up to the frequency polygon, notice it went down, up, stayed the same, up, down. And so it was very non-uniform in the direction that it went. A frequency polygon and a histogram can go up and down. An ogive, because we're talking about cumulative frequency, it's always going to increase. This tells me that there are 2 values, 679 or below. There are 2 values, 689 and below. Well, since I'm including everything below, I can't drop back down. I have to stay the same or go up. So please look at the frequency polygon and ogive and do some practice there.